We'll go ahead and get started. Okay, so on example 4, we're going to kind of start with very, very simple stuff that have something to do with the unit circle. So when you're solving a trigonometric equation, you're either going to need your unit circle or you're going to need your calculator. It just kind of depends on how the numbers work in the individual problem then. Okay, so on this first example, let me close that for a second and reopen that because it's starting to mess up. So I'm going to use this unit circle to kind of show you how you do. This is about as easy as an equation can possibly be. Okay, first thing we're going to do on this one is you're going to give a general formula for all the solutions. We didn't do that last time. What we did on the previous 3 problems is we solved it on the interval 0 to 2 pi. So if I have you solve an equation, I'm generally either going to say, I want all the answers on an interval, or I'm going to say, give me a formula for all the answers, because this trig equation has an infinite number of answers to it. Okay? So let's take a look at how this would go. Well, first of all, this is already isolated. You always want your trig function to be isolated before you can look at your unit circle and figure that out. Now, the next step's very simple. There are 2 places on this unit circle where the sine takes on a value square root of 3 over 2. Where are they? Here, right? And there. How come? Because the sine is the y value. Agreed? Okay, so that means one answer, and we're going to do this in radians. One answer is pi over 3. The other one is 2 pi over 3, like that. Okay, but we're going to write a formula for this. We're not, because there's an infinite number of answers. And you already know that because you can make your angle go further and further laps around the circle, right? So you just get infinite answers. So what you're going to do, when you write this answer, you write it like this. So you want to write this down exactly like this. You have to do set builder notations. You say set of x, and then you say x is equal to pi over 3, like that. Then what you do is the period. Okay, now the period of a basic sine was what? There's no, like if you graph sine theta, what's its period? 2 pi, right? So what you're going to do is you're going to put a 2 pi k there, like that. So what you're saying is k is an integer. If you add 2 pi to it, you get the same answer. Do you agree with that? You take another lap around the circle, you're back to that same point on the unit circle anyway, right? And k can be a negative number, so it could be an integer that's a negative number as well. Then you say comma, then you say x equals the second answer, 2 pi over 3. Then you say plus 2 pi, sorry, 2 pi k again. Then you say k is an integer, like that. Okay, let me take a drink so I can get my throat cleared up here. Okay, you guys see what I'm doing there, okay? Now, the thing on that is the period of a sine is 2 pi, so that formula gives you all of the possible answers that you have. All right, is there any question about that? Okay, all right, so if I say write a general formula, then that's what I'm talking about. If I wanted you to have an interval, then that would be the answer. If I said solve it from 0 to 2 pi, then you would have that pi over 3 and 2 pi over 3, but I want a formula. All right, any questions?
What was the interval sign again?
What's that?
The sign for interval? Oh, yeah, it was the z with the line.
Oh, this thing. Okay, instead of saying k is an integer, you can go k epsilon like that. That's what you're talking about. That's just kind of an abbreviation for k is an integer. Okay. Now let's go ahead and let's go to a tangent. Again, these are kind of starting off with just basic unit circle analysis here. Okay, number 5 is already isolated. You have a tangent of theta, it's already isolated. So what your job is to figure out on the unit circle where the tangent takes on a value square root of 3. Well, there's actually 2 places. And, well, one clue is it's the one that has a square root of 3 in it, right? I just look at it like this, okay? If you did like the tangent of pi over 3, the tangent of pi over 3 is y over x. Y is square root of 3 over 2. X is 1/2. 2's cross out, so that's an answer. So without a doubt, one of the answers is going to be pi over 3, right? Okay. There's one other place on this unit circle where the tangent would be square root of 3. Where do you think? If you look at the unit circle, there's one other place where that happens. What quadrant? 3. Okay, right. Because remember, if you did a negative over a negative, wouldn't you get a positive there? So also at 4 pi over 3, if you did y over x, that would give you the same thing. Okay, so the idea with this is if you look at this point right here at 4 pi over 3, here's what happens. If you do the tangent of 4 pi over 3, it's easy to see. You would just have negative root 3 over 2 divided by negative 1/2. Same thing happens, and the negatives cross out. So there's actually two answers. There's pi over 3, and there's 4 pi over 3. And if I wanted you to solve on the interval 0 to 2 pi, that would be your two answers. But what I'm looking for in this problem is I'm looking for a formula. Okay? So watch this real carefully. It's very similar to the last problem. So we say set of x, and we say x is equal to pi over 3, like that. Okay, but now this is where you got to be very careful on a tangent. If you graph a tangent, what's the period? It's not 2 pi. What is it? It's pi, exactly. So the period's pi, so now you would say pi k, or k pi, doesn't matter which order you do that in. So I'm just going to say plus pi k like that. Okay, now I'm going to do something unnecessary on purpose, and I want you to pay attention to this and see if you catch this. Okay, then we could also say x equals 4 pi over 3, which is the second answer, plus pi k, and then again we'd have to say k is an integer, so you could use that symbolism like that. Okay, so just like the last problem the period was 2 pi, so I said that. So plus pi k plus pi k. Now I want to see if you catch something. This part right here is unnecessary. There's a reason why you don't have to put that there. Any idea why? Okay.
Pi k.
Over 3 plus
Okay.
pi k is.
There you go. Good. Okay, it's built in. So let me show this to you. It's actually unnecessary because notice what happens. If k is equal to 1, you have pi over 3 plus pi times 1. Okay, so if you plug that in, well, what do you have? You would have pi over 3, and then what you would have here is you'd get a common denominator for that. That would be 3 pi over 3, so doesn't that give you 4 pi over 3? So he's right. He's saying that this formula right here is going to give the next answer anyway. Okay? Now, there's a reason why I know this, too. Okay, notice that, what is the relationship between these angles? Aren't they on a straight line? Yeah, and what is that angle that's on a straight line? That's pi, right? The period's pi, so that means if you add pi to that, you're going to get that. And if you add pi to that, you're going to be back there over and over and over again. If you add pi, you're just going to keep getting in the same place. Does that make sense? The tangent, the answers are always 180 degrees from each other. That's the way it works. That's because the period is equal to pi. So it means that this part is really unnecessary. So the best way to write the answer is to just write this. And that's the way it always works on a tangent. You say set of x is pi over 3 plus pi k, and that's all you got to write. And then you also got to write that k is an integer. So that would be your final answer to your problem like that then. Okay, does that make sense? That's unnecessary. Everybody with me on that? Why that's unnecessary? Okay, it generates the second answer. That's the thing. All right? Okay, any questions with that? Okay, so that's kind of stage one of your trig equations. What all of these have to do with is you have a very basic trig function equals something that falls on the unit circle. That's how you start. Now we kind of transition to something a little bit different on this next problem here. If you look at this kind of looks like a quadratic equation. Now I'm going to show you something before I do this problem. I want to show you something. You don't necessarily need to write this down, but if you were in college algebra or pre-calculus or something, whoops, let's kind of review how you would do a problem like this. How do you do a problem like that if you're like in basic algebra? You factor. And if that doesn't work, what do? You go to the quadratic formula. So the way this would work is if you did the algebra problem, you would factor, and that would be 2x times x to give that. You would have 1 times 1 to get that. Then you'd have 2 minus signs. The reason you have 2 minus signs is because you would have a negative 1x and a negative 2x adding to negative 3, correct? Okay, then what did you learn to do once you got it factored? Then what's next? Take each factor, set it to 0 and solve, correct? So you would have 2x minus 1 equals 0. You can solve that equation in your head. That's 2x equals 1. Divide by 2, you get 1/2. Okay? And then if you do this one, you have x minus 1 equals 0. Add 1 to both sides, you get that. Okay, now when we do trig, it's almost the same idea. Does that look familiar to everybody? Okay, that's basic kind of college algebra stuff. Okay, now trig, we're going to do the same approach. So when we do this, we got one side equal to 0. So we're going to go ahead, and this is what you need to write down, is let's go ahead and factor this then. Okay, so the first term is going to be 2 cosine theta, so I'm going to say 2 cosine theta, and I'm going to say cosine theta like that. And that's the only possibility there is. Okay, and then the last term is the 1, so the only possibility on that's a 1 and 1. You kind of do this by trial and error. Okay, and then the middle term is negative 3 cosine theta. And you can do this in your head, but you're foiling. So if you multiply that out, that would be 1 cosine theta. This outer term would be 2 cosine theta. And what you're wanting is those things to add up to negative 3 cosine theta, right? Well, how do you make 1 and 2 add to negative 3? 2 negatives, right? Okay, so you would have a negative there, and you would have a negative there. Okay, and that's your factoring. Now, if you're solving a trig equation and you factor, please make sure it's right. Multiply it out in your head and make sure you factored it right. Don't waste your time. Okay, everybody with me okay on that? With the factoring? Okay, sometimes there's background issues that students encounter with factoring and stuff in this class. Okay, so we do that. That's factor. Now, what do? We take each factor and we set it equal to 0, just like you'd do in like the quadratic equation over here. So we do that, and then once we do that, we're going to have to go back to the unit circle now. So we do that, okay? All right, so now what I'm going to do is I'm going to solve these equations, and you can rearrange this stuff in your head. You can move the 1 to the other side, so you'd have 2 cosine theta equals 1. Then you can divide by 2, so you would have cosine theta is equal to 1/2. And then that just goes back to the unit circle. You're going to figure out where the cosine's 1/2, what angles that happens at. Then this one, you could add 1 to both sides, and you'd get cosine theta is equal to 1 like that then. Okay? Everybody with me okay with what I'm doing so far? So it looks like just basic algebra, okay? Now, we're ready to go to the unit circle here. And remember, we're not doing a formula. If you read the directions to the problem say solve on the interval. So from 0 to 2 pi, we want to find all the answers. So it's very simple. On the unit circle, the cosine takes on the value of 1/2, 2 places, there, and the other place is here, right? Cosine's positive in those 2 quadrants. So that means one answer is pi over 3, the other answer is 5 pi over 3. Okay, so as I put this together, this is going to give pi over 3 and 5 pi over 3. Those are the 2 answers there, okay? All right, now how about the cosine theta equals 1? Where is the cosine equal to 1? At what angle? 0. There's only one place that happens. It happens there. The cosine's the x value on a unit circle. So what that means is the third answer and final answer would be at 0 radians like that. Okay, so we've got 3 answers to this problem. So we just write this like this. On my math lab, your homework, you just list the solutions. I don't care what order they're in, really. And you just put it in a set brace like that. That's it. There's 3 answers. Okay? So what I did is after I factored, there were 2 answers to where the cosine's 1/2, and there was 1 place where the cosine's 1. Okay. But hold on. You guys are looking at me funny, and I just figured out why. What should that be? 0. Why I put a pi there, I have no clue. I even said this. Where is the cosine 1? At 0. Okay? All right.
You have to put the 0 in?
Oh, yeah. It's an answer to the problem. Okay? And the thing is, if you look at my thing here, see how this says 0 less than or equal to 0 less than 2 pi? So that equal to means that 0 is included in that. Now, 2 pi is not included. Everybody got that? You have to pay attention. You won't want to mess up on problems because of that. 2 pi would be another place where the cosine's equal to 1, right? But that is not included, but the 0 is. Okay, all right, how's that look to everybody? Okay, tell me something. Some thumbs up, sideways, down, what? Okay, is that okay? Now, I want to show you on the calculator. Get your calculator out if you brought it, because the other thing that helps you understand equations is the way that you can interpret this graphically. And this is a worthwhile thing to do a couple of times when I'm teaching this, is you can check your answer on a calculator. It's very easy. So what we're going to do is we're going to do this basically. We're going to put in the left side of the equation in the calculator. So we're going to go, first of all, make sure you're in radian mode. That's important, is radian mode for graphing. And then for y equals, we're going to put in 2 cosine squared. You have to usually put in cosine squared like this. Okay, so be careful about that. You just got to have the cosine and the whole thing squared. That's how most of the calculators force you to do it like that. Then you're going to have minus 3 cosine, use your x key like that. Everything's got to be an x. And then you have the plus 1. So you want to get that put in. We've done a lot of graphing. We hadn't graphed anything like that. That's something you'd want to use your calculator on. Okay? So once you get that put in, now you want to adjust your window. Okay? I'll slide this over here just for a second here. And then you can see kind of, if you need to see how that was put in, you can refer to that. Okay, now for the window, I'm going to go like this. Since I'm solving on the equation 0 to 2 pi, you just want to go 0 to 2 pi. Max, go to 2 pi. The scale, it doesn't make a bit of difference what that scale is. You can leave that as anything you want to. Don't even waste your time. The y's, probably negative 4 to 4 is good enough. It probably doesn't make any difference. So I'm going to slide that over there. And if you can refer to that once you get that set up, now you type graph, and you'll get what your function looks like. I may need to adjust the y, but I think that's probably okay. I think that'll be fine. Okay, so this thing will come back down. We got 3 answers on this problem. Now, if you look at this, I don't know how well you can see this, but there are 3 places where it crossed the x-axis. 1, 2, 3. It crossed again at 2 pi, but that's out of range. So all you really got to do to verify that you're right, I can zoom on this a little bit too sometimes. So if you go through and do this, just trace. So let's trace out our answers. So here's how I know this. So if I go trace pi over 3, like that, okay, all it's going to do is blink on that place right there. See, it's equal to 0. That's what it's supposed to be, all right? If I want to take another answer, like if I trace at 0, okay, it's going to spit out that y is equal to 0. It's going to blink where it's supposed to. Okay, then if you trace at 5 pi over 3, like that, same thing happens. Okay, so all you're trying to do when you verify this is where are those things on the x-axis on the graph? And they are. Does that make sense? So you have the ability with technology to tell you right. It opens up what you're doing in a trig equation a lot. So I recommend you do that some. Get your calculator out and see if you're right, and that'll help you. Okay? Anybody have a question with that? Okay. All right. So now let's push on and do a little bit more with this. We're kind of focusing on factoring right now. Okay, so the general thing that you want to do when you're solving a trig equation, and if you have a power that's a second power or higher, then you start focusing totally on factoring. Okay, just like if you were in college algebra, if you had a problem like this in college algebra, let me erase that like this. Well, what did you learn how to do? Okay, hopefully you learned that one side must be 0, right? So you would have like 2x squared minus x equals 0, then you would factor. How do you factor something like this? Do you draw 2 parentheses or do you do something else? Does it have a common factor? Let me ask it that way. Yeah, it has an x in both positions. So you take an x out, and then you would be left with that. Then you set each factor equal to 0. Okay, now some of you are going to have to review factoring. It's just the reality here. You're going to start using it a lot. So what I'm going to do on this one, what you want to do is you want to leave that the way it is. You want to move the sign over to the left side so that you're set equal to 0. So you must be set equal to 0. That's step one, is make sure you got that. Now, what's the common factor in this one? It's a sine theta, right? So you take a sine theta out like this. So you have sine theta And then what's left over is 2 sine theta minus 1 equals 0. Just make sure it's right. Every time you factor something, check it. Sine times sine, sine squared, right? Sine times 1 is sine. Everybody with me on that? Okay, so don't forget about common factors. Now what you do to finish this up is we're going to set each factor equal to 0. So we have sine theta, that's your first factor. Set that to 0, look at the unit circle and solve that. Second factor is this. So you want to do 2 sine theta minus 1 equals 0 and do that. Let me erase this mess right there. So we do that. Okay? Now I'll slide down the unit circle here so you can kind of see what I'm doing here. All right? All right, so far okay? All right, now let's take a look at this. Where on the unit circle is the sign equal to 0? There's 2 places, right? The sign's the y value, so it looks like what you would have is you would have theta equals 0, and you would also have pi. Those are 2 answers. And they fit within our interval. The interval that we're solving on is 0 to 2 pi, but excluding 2 pi. So those are 2 answers, okay? So if you look at this one now, you would move the 1 to the other side, so you'd have 2 sine theta equals 1. Then you can divide by 2. So you would get sine theta is equal to 1/2, okay? So there's 2 places where this happens. The sine is 1/2 there and there. So that means you would have an answer of pi over 6, and you would also have an answer of 5 pi over 6, like that. So when we're putting all the answers together, we're going to have 4 answers on this one from the unit circle. Okay, so that's how that goes. So the final answer, I don't care what order you put it in, 0 pi, pi over 6, 5 pi over 6, like that. Okay, that's your answer. Okay? All right, so you got the factoring aspect of that, and then once you get the factoring, these problems are designed so if you factor correctly, then you can interpret the unit circle. If it doesn't fall in the unit circle, your only choice is to get the calculator out. And we'll do a couple like that in a little bit here. Okay, is there any question on that? Are we pretty solid with what I'm doing there? Okay, all right. Let's do one more that's got factoring, and then we're going to start looking at ones that have identities, and then we'll close off with ones that have period changes in them. So there's like different categories of these things that you have to learn how to do. Okay, so if I look at this problem, I've got a power. That's the key. I've got a power which tells me I have to factor, and I've got one side 0. So we're good there. So what we are ready to do on this particular problem is we want to factor this. Okay, so I got to know what your guys' factoring skill is. How do you factor something like that? There's a common factor, right? What's the common factor? Cosecant. There's a cosecant in both positions, and you got to work with the one with the lower exponent. Okay, so you're going to write this like this. You take out the cosecant of theta, and then what you're left with is this is going to be cosecant to the 4th theta minus 4, like that. Okay, so I just take that out. Now you've got a couple of choices. Okay, it's up to you. Now this is what I would personally do: is this factors also. Okay, you spot what this is. What's special about the number 4? It's 2 times 2. That's a perfect square, right? What is something to the 4th power? That's also a perfect square. So it's like something squared times something squared. So hopefully in your background, we haven't seen this yet, but if you encountered something like this in an algebra class, like if you had that, the way you factor that is you go x and x, 3 times 3 to get 9, and then plus and minus. That's called the difference of 2 squares. Does that look familiar? Okay, need to know that. What if you had something like this? X to the 4th minus 81. Well, then you would go like this. You would have x squared and x squared. Then you would have 9 times 9 with a plus and minus. Same thing. However, this one would factor one step further, and a sum of 2 squares never factors. So x squared plus 9 is prime. That doesn't factor. But this one would factor again. It would go x and x, 3 and 3 to get 9 with a plus or minus. Does that look familiar? Okay, so you got to learn to spot your factoring. If you need to brush up on your factoring, you need to do it now, because it's going to show up in this section quite a bit, and the next couple of sections actually. So what I'm going to do on this one then is I'm just going to bring this down, man, I'm going to go ahead and factor this thing like this. So I'm factoring this. And this goes like this. It's a difference of two squares. So you would say cosine squared or cosecant squared theta, cosecant squared theta. 2 times 2 gives 4. Then you'd have a plus and minus like that. Okay? And you could do that. Now, this one doesn't factor. Cosecant squared theta plus 2 doesn't factor. Okay? This one also doesn't factor. So what you're going to do is you're going to do these things. You have 3 factors. So you need to set each one equal to 0, then solve using your unit circle. So we have cosecant theta equals 0. We're going to solve that. We have cosecant squared theta plus 2 equals 0. We'll solve that. Then we have cosecant squared theta minus 2 equals 0 like that. Now all this algebra, I'm just trying to show you the connection between what you've hopefully learned and what you're going to see in the trigonometry. Okay? All right, so let me bring this unit circle down. Let's take a look at this. Now here's the way I would look at this. If I have a cosecant, you can change that into a sine if you want to. That's a better way to do this. So the cosecant is r over y. Okay, and you got to think about this a little bit. Don't let this bother you. Is there any place on the unit circle where r over y would be 0? Think. What's r in a unit circle? 1. Is there any way that 1 over y would ever be 0? Can you take 1 and divide it by a number and get 0? No. So there's no solution to this right here. That has no solution. That factor right there didn't generate anything. Now, if you don't like looking at it that way, you're also more than welcome to look at it this way. You can change a cosecant into a sine by doing the reciprocal. So if you did the reciprocal of 0, you would get something that's undefined, right? So that doesn't give you anything. That's normal. That happens on these problems, okay? Okay, now go to the next one. So what you do is subtract 2 from both sides. You'd have cosecant squared theta equals negative 2. Okay, how do you make that cosecant squared become a cosecant? What do you do to both sides? Square root, exactly. We've seen that before. So we're going to do square root of both sides. So if we do that, we would have cosecant of theta, and don't forget the plus or minus when you do that to both sides. That's very, very important. Okay, now I want you to look real carefully at this. What kind of number is the square root of a negative? What do we call that? Imaginary, right? So that you're not going to find any place on the unit circle where you have imaginary numbers. So the same thing happens on this. That is no solution. So that factor gave us nothing. Okay, you still got to factor it and you got to find out. Sometimes factors don't give you anything. Okay, so now we move over to the last case and we do this. So now we're going to move the 2 to the other side so that we get this. Now we're going to square root both sides like this. And when you do that, you're going to have the cosecant of theta is equal to plus or minus the square root of 2. And that plus or minus is super important because if you overlook it, you're going to miss some answers. Now, it turns out that if you looked at this point on the unit circle right here, if you did the cosecant of 45 degrees, what you're really doing is you're doing the reciprocal of that value, right? The sine is y, the cosecant is the reciprocal of that, so that's 2 over root 2, right? And then if you rationalize that, you would have 2 root 2 over 2, so you would have square root of 2, agreed? So that means in this unit circle, how many places would the cosecant turn out to be either a plus radical 2 or a minus radical 2? Not 2. How many? 4. There's something in every quadrant, right? So what you would have is you would have an answer here, you'd have an answer there, one there, and one there, because you can have negative answers because of the plus or minus. So that means that the answers on this are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. That's it. Okay, and again, since we're solving from 0 to 2 pi, we found every answer of the problem there. Okay, so again, there's that factoring issue that you got to make sure you have in your background, and then setting each factor to 0, you got to look at the unit circle the right way. Okay, is there any question? Anything I need to clarify on that? Okay, tell me. I don't know. I just see a bunch of blank faces. Okay. All right. Okay, let's move on. Let's do one that's got a identity in it. A couple of them that have identities. Then we'll close off with the last page. I'm going to do one example where you have like something to the 2 theta or 4 theta or something like that. Okay, what you encounter in this now is, and this is a general rule of thumb, you're solving a trig equation. This has 2 different trig functions in it. So you want one side to be 0. There's no doubt about that. Let's start that way. Let's start just by having secant squared theta minus 2. When you move the tangent to the other side, you're going to have minus tangent squared theta equals 0 like that. Now, you're going to have a seriously difficult time factoring this thing. In fact, you aren't going to get anywhere on this if you do factor it. So, so what I'm going to do is I'm going to pull out an identity. Now, you have an identity with a secant squared and a tangent squared, right? If you don't know it, you want to look it up. So I'm going to write that identity down. The identity goes like this. Tangent squared theta plus 1 is equal to the secant squared theta. That's a helpful identity that we've learned before. Okay, we've seen that. So what I'm going to do is you can substitute in for either one of these things. To me, I would personally rather have a tangent in my problem than a secant. It doesn't make any difference, though. We can do secant. One of the benefits of secant is it's just a cosine, okay? So let's go ahead and let's do this then. Let's just substitute in for the secant, this right here, okay? Leave the tangent the way it is. I'm just going to choose to do it this way. So let's replace that with what it's equal to, which is tangent squared theta plus 1 minus 2 minus tangent squared theta equals 0, like that. Now we're going to collect like terms. This is a great problem too. I love what happens on this one. What do you see happening? What? I like it when that happens. I love it when that happens. Now what do you have? You have 1 minus 2 is negative 1 equals 0. Everything canceled out. So now you still have to give me the solution of this equation. So this thing right here is not equal to each other. When you solve an equation, you always have these possibilities. You generally get an answer or some answers. Sometimes you get no answer. Sometimes every number works. What do you think's the right answer on this? No solution, exactly. This thing right here is a contradiction. Okay, if everything cancels out, spell that contradiction, okay, then that means it's no solution. That's what would happen on that problem. Now, if you tried to graph that on the calculator, I do want you to do something with your calculator on this because it'll help you understand something that's kind of important connection to make in geometry. So I'm going to graph this like this. The way I have to put this in a calculator is like this. Now I'm going to do this like this. I'm going to have you put the left side in your calculator. If you're going to put a secant in, the only way to do that is to go 1 divided by parentheses cosine of x, like that, and then the whole thing squared, like that. Now you can write that like that if you want to, like that. That's how you do 1 over secant squared, because we know it's 1 over cosine. Then I'll put in the minus 2 like that. Okay, now I'm also going to have you put in the right side. I'm going back to the beginning. If you put a tangent in, you would go like this. You would have tangent of x, then square like that. Okay, and I just want to show you something. I'm going to do this in a certain window that's where I'm just going to use the same window I had on the last problem. So you want to get everything put in like that. Then if you look at your window, I'm just going to leave the same thing I did on the last problem. 0 to 2 pi, and then I'm going to do negative 4 to 4. Now, if you set it up this way, what you're looking for is where those two graphs cross. Okay, that's what the meaning of that is. So if I type graph now, here's what happens. This is right now what's coming out is the graph of the left side of the equation. That comes out. That's the graph of secant squared theta minus 2. That's a secant shifted down 2. Now, out comes the tangent squared like this. Okay, this is a neat problem. Okay, now if you look at that, are those things intersecting? Probably not. It looks like they might intersect there, but they don't. So what's happening is, if you look at the intersection of those two graphs, since they don't intersect, that's why it's no solution. Does that make any sense? Okay, that's what happens. That's a very good connection to make on that. If you get no solution, that's what it has to mean. Okay? All right, let's move on to this next one here and take a look at this one. So again, when you have a second power, or any power for a matter of fact, you want one side equals 0, and then you want to start thinking factoring. Okay, that's the first thing you got to learn from this. So we're going to have cosine squared theta. We're going to multiply this out on the right side, so we'll have 3 minus 3 sine theta like that. Now, next thing you got to do is you got to get everything on one side set equal to 0. Okay, start the problem off that way. You have to. So I'm just going to move everything to the left side. So that's minus 3, and then plus 3 sine theta equals 0, like that. Now, you can try to factor that if you want to, but I promise you if you do, you will get nowhere. So what you got to do is you got to think about trig identities. So you have two trig functions, and you know that you have the identity sine squared theta plus cosine squared theta equals 1. So you make a choice. To me, the best thing to do is, since you already have a sine here, change the cosine so it has a sine in it. So what I'm going to do is I'm going to take this identity and I'm going to rearrange it so I have cosine squared theta is equal to 1 minus sine squared theta. Now what I'm going to do is I'm going to take that cosine and I'm going to replace it to what it's equal to. You see what I'm doing? I want my trig equation to have one trig function in it. If I do that, it helps tremendously. So change this to 1 minus sine squared theta. Leave everything else alone. Collect like terms, and then we'll see if we can get this thing to factor or not. Okay? Well, here's what I see. I'm going to have a negative sine squared theta. I've got a 3 sine theta. And then the other thing I have is 1 minus 3 is going to be minus 2. So I just collect the like terms like that. Okay? Now that's beginning to look more like a factoring problem. Now this is a personal preference that I have. You could go ahead and draw your two parentheses and start factoring if you want to. But what I like to teach students is that if that squared term has a negative in front of it, change it to a positive. And you can always just do this in your head, because it's generally easier to factor a trinomial if the squared term is positive. So that's why I'm doing this. So that will just change to sine squared theta minus 3 sine theta plus 2 is equal to 0. Now we got something that we can factor okay. All right, you guys following what I'm doing okay? I got that identity because I had two trig functions. That's generally why I'm doing that. So now let's factor this. Okay, so I'm going to move this over here. So what I'm going to have is, when I factor this, I'm going to have the first term is a sine squared theta, so that's got to be a sine theta and a sine theta like that. The last term is 2, so it's got to be a 1 and a 2. Okay, like that. And then the inside term has to be negative 3 sine theta. You don't have to write all this out. You can process this on your head. That's 1 sine, that's 2 sine. So how do you make 1 sine and 2 sine come together to make negative 3 sine? Two negatives, right? Okay, so that's got to be a negative like that. So that's how your factoring goes. All right, is that solid? Okay, well, I a lot of times see that it's not solid with trig students. So you get that factoring down if you need to review that. Okay, now what I'm going to do from here is I'm going to take each factor, like I've been doing, and you're going to set each factor equal to 0. So you have sine theta minus 1 equals 0, solve that. Then you have sine theta minus 2 equals 0, solve that. The unit circle will give you the answers to those equations. Okay, this one, move the 1, add 1 to both sides, so you have sine theta equals 1. This one, move the 2 to the other side, so you have sine theta equals 2. Now it's unit circle time. Okay, first of all, on the unit circle, where is the sine 1? What angle gives that? Pi over 2, right? That's the only place. So the answer to this equation is theta is pi over 2. Okay, where on the unit circle is the sine 2? Nowhere. Exactly. The biggest value the sine ever hits is 1. Agreed? Okay, so this right here has no solution. And that happens very frequently, as one of the factors doesn't give you anything. So that means the only answer to this problem is pi over 2. That's it. Okay, that's the idea. So you just write the solution as It's only got one answer, pi over 2. And what we're doing is we're solving it on an interval. Okay, does that make any sense? Okay, so it makes sense why I did an identity. Okay, because if you can't factor something and you have different trig functions in there, try to get it down to one trig function because your goal is to factor. It has to be that way, okay? All right, let's look at one other factoring situation, then I'll finish up with that number 12 to finish this section up. So with this one, what we're going to do is we're going to look at this one. This doesn't have any powers in it. And the directions to the problem say use your calculator to solve. So I'm going to show you two ways to do this. Probably the best way to do this, to me, is just do this. Just move the 2 to the other side. So you have the equation 6x minus 5 sine x minus 2 equals 0. Okay, and then what we're going to do is we have to do this on the calculator because you aren't going to get any factoring going on there. And you can't isolate x. You can't just get x by itself on the side because of that sine x. So what I'll have you do, and just do this with me with your calculator so you know what you're doing. I'm going to erase what I have from the last problem. And then I'm just going to have you put in the left side of this equation. Okay, we're just going to graph that. Okay, so when I put that in, I'm going to put in y1. I'll put in 6x. Then I'll put in minus 5 sine x. There's no telling what kind of graph we got here. And then we'll have minus 2 like that. Okay, so I want to get that set up kind of like that. And then I'm going to look at my graphing calculator, and I'm going to see on the interval. You're supposed to do this from 0 to 2 pi. I think I forgot to write that on there. So you want to write a note. You're going to solve on the interval 0 to 2 pi. So let's just use the same window that we had on the previous couple of problems. Go 0 to 2 pi. And if you do that, that would be a pretty decent viewing window. Okay, I'm going to get that over there so you can see that if you need to see it. Okay. All right, well, let's go ahead and graph. In Radian mode, let's see what we have. So what your goal is on this one is you're trying to see where it crosses the x-axis. Okay, so far it looks like it only crossed one time. So your job is to figure out what that point right there is. The way you do this is like this. Okay, let me slide this thing over here again so I can write on this thing a little bit. Okay, so what I have is your job is just to find out what that point right there is. So here's what you do. You usually do this in college algebra some. You go second trace to open up the calc menu. And what you're doing is you're finding what we call a 0. A 0 is just, where is it on the x-axis? That's what you're doing. So you get that option to come out, then you press enter. The calculator is going to ask for a left bound. A left bound would mean you need to just be somewhere to the left of it. So you take your cursor key, and you can just kind of adjust that until you get somewhere to the left. It may take you a while to get there. My calculator is sometimes a little slow on here. Okay, so it's coming down. I want to get a little bit to the left right there. Okay, and it doesn't matter where. As long as you're to the left, you're okay. Press enter. Some of the calculators, they'll all have a triangle. Some will have a vertical line. Now it's going to ask for a right bound. A right bound would just mean get over here somewhere. Get to the right of it. So take your right cursor key now and just start moving a little bit to the right. And then once you're convinced you're to the right of that intercept, press enter, and you'll get that. Then when it says guess, press enter one more time, and out will pop the answer. You'll know you've done this right because y will be 0. So there's your answer. We just round that off. So we would say that point is about x equals 1.06. That's it. That's how you solve that graphically, is to do it like that. That's probably the simplest way, is to get everything on the left side, graph that, and then see where it intercepts. Okay, does that look okay? Okay, that's kind of a cool thing to do. So you can, some problems are too hard to do algebraically, so sometimes you have to use technology. You have no choice. Okay, all right. A good potential calculator part of a test. Okay, you got to do that on a calculator. I always test over that one thing, something simple like that. Okay, the last one is the hardest one in the whole section. It's not that it's hard, it's very long. It takes a lot of work. So the key thing you're going to see on this with your homework is if you have something like 2 theta or this argument So far, every trig equation that we've solved has just been has a theta. It's had sine theta, cosine of theta, just theta. But once I change that, we have a period change going on in the problem. And you have to use a certain methodology to do this. So you have to follow this procedure exactly or you won't get anywhere on the problem. So if you want to write these steps, you can. I would recommend you do that. What you always do is you always isolate the trig function. Okay? Whatever it is. You don't have to get one side equals 0. You only get one side equals 0 if there's exponents. Second power, third power, that kind of thing like that. Okay? Second thing you do is you do the inverse of both sides. Okay, follow this procedure exactly the same way and it'll help you to get this right. There's other ways to do it. This is just what I think is the best. So what I'm going to have you do is we're going to take the inverse sine of both sides of the equation. Okay, like this. So let's go ahead and get that written down then, because we've worked with inverses. We've done some of this. Okay, we did a little bit of this last week. So if you do the inverse of the sine, what does that become? What does that left side become?
Sine theta.
4 theta, the argument. Okay, if you undo a sine, the argument's what you get. Look back on your notes on that. Okay, that's 4 theta. That's all that is. Okay, that's why we did that. Okay, now we're going to do this side. So we're going to end up looking at the unit circle when we do square root of 3 over 2. So that's step 1. Now, what you're going to do is look at your unit circle. There are 2 places where this happens. The sine takes on the value of square root of 3 over 2 at pi over 3 and also at 2 pi over 3. So the next thing is you want to write 2 things down. You want to say 4 theta is equal to pi over 3, and then you want to say 4 theta is equal to 2 pi over 3. Okay? Now you got to have that 4 theta there. Now what you're doing on this one and what's happening is the period is changing. If you look at this problem, the period, the formula is 2 pi over omega. Omega is 4. So you have 2 pi over 4, you have pi over 2. Now here's what that means, is every time pi over 2 goes by, you're going to have 2 answers to the problem. So what you have to do, and this is the part you don't want to forget, is if you had a basic sine, the basic period of a sine is 2 pi k. So write that down and then do the same thing down here. Okay, we're going to change the period in the next step. Okay, so what you do is you do the inverse and then don't forget when you get those 2 answers to put the plus 2 pi k. You'll see why in just a minute here. So now what we're going to do is we're going to divide both sides of this equation by 4, or it's even better if you multiply both sides by 1/4. It just looks a little cleaner if you do that. Okay, so when I do that, that's going to cross out. That's going to leave what theta is. Okay, and then if you do this, you're doing this. So you're just doing pi over 3 times 1/4. If you do pi over 3 times 1/4, what do you get? You get pi over 12. So that's really where one of the answers is pi over 12. The period changed. Okay, then you do this. If you do this, you're going to have 2 pi k times 1/4. Well, the 2/4 is going to go to 1/2. So now you would have pi k over 2 like that. Well, that's what the period of the sine of 4 theta is anyway. So that's what that pi over 2k represents, is the period. Okay, so does that make sense what I did? When I had the 4 theta, see, I had to multiply by 1/4 because I want to find what theta is, not what 4 theta is. Now I do the same thing here. Multiply by 1/4, multiply by 1/4 here. Okay, when I do that, you're going to have theta there. Now just multiply it out. Okay, so if I do this, I'm going to have 2 pi over 3 times 1/4. Okay, you can reduce the 2/4 to 1/2. So that's going to give pi over 6. You can do it on scratch paper if you want to. Okay, same thing's going to happen here. If you do 1/4 of 2 pi k, I've already done that, but I'll do it again. That's going to give pi k over 2. Okay, like that. So what we're going to do is we're going to get the general answer, and then we're going to get specific answers. So let me show you how to finish this up. Okay, so if you wanted to get the general formula, what you would have is you would have this. Okay, the general formula, the answers would be written like this. Set of x or no, set of theta. Theta is our variable. So we'd say set of theta such that theta is pi over 12 plus pi k over 2, comma, then the second answer is theta is pi over 6 plus pi k over 2, with k being an integer. That's how you would write the general form. Okay, and anytime you have like that argument of the trig function is anything other than a variable, you've got to take this approach. So that is the general answer to the problem right there. That's the general answer. So what we've got to do now is we got to get the specific answers. Okay, so let me show you how to do this. And actually, I'm going to show you what my math lab does. You can do it this way, but you can also just start looking for patterns. So here's what you do. First thing you do is you let k be 0. Okay, if you let k be 0 in this formula, what you're going to have is you're going to have theta equals pi over 12 plus pi times 0 over 2. Okay, everybody agree that that would just be pi over 12. Because k would make that pi k thing goes to 0. So that's your first answer to the problem is pi over 12. I'll kind of highlight this as you go. That's answer number 1. Okay. Now what we got to do is go to this second part here. So we're going to do theta equals pi over 6 plus pi times 0 over 2. That crosses out. Answer number 2 is pi over 6. Okay, both of those angles are in quadrant 1. That's 2 answers. So we just have to push on. There's a lot more answers on this problem. So we push on like this. Now I'm going to do this one more time, then I'm going to help you find a pattern on this. Now we go to k is 1. Now remember what we're doing is we're looking at this formula and we're looking at that formula right there. That's how you get the next set of answers. So now we go theta is pi over 12. Then we say plus, now this time let k be 1. So we have plus pi times 1 over 2. You got to work that out. Then over here you got to say theta is pi over 6 plus pi over 2, and then you got k equals 1. And then you'd have to go to k equals 2 and k equals 3. Eventually your answers will get bigger than where they're supposed to on the interval. So when we do this, it's going to go like this. We're going to have pi over 12. If you get a common denominator, that's pi over 2. So you could write that as 6 pi over 12 like that, right? 6 pi over 12 is the same thing as pi over 2. So that's going to give you another answer, theta equals 7 pi over 12, like that. So there's our third answer. Okay, so we got that now. Okay, then we got to go over here and work this out. So this one is pi over 6. Get a common denominator, change this to 3 pi over 6. So I'm just working with a common denominator here. So that's 3 pi over 6. So that would be 4 pi over 6, like that. And then that could be reduced to 2 pi over 3. Okay, so what I've got now is I've got 4 answers. You guys see what I'm doing okay? Okay, students always hate doing this problem. It's a lot of work. Okay, so I got 4 answers. But do you have any idea how many answers there are on this problem? Let me explain that. Okay, the period's pi over 2, right? There was 2 answers. The first 2 answers were in quadrant 1. The second 2 answers are in quadrant 2. We're going to have 2 more there. 2 more there, what's the grand total? 2, 4, 6, 8. There's 8 answers to this problem in one lap around the circle. So now, you can continue to do this. You could go on to k equals 1 if you want to. Then you could go to k equals 2. Or you can do this. This is what you would rather do. Okay, first of all, I'm going to write down the first 2 answers. Pi over 12, 7 pi over 12. Those are generated from the first formula. Then I've got pi over 6, and then I'm going to go ahead and write the 4 pi over 6. I'm not going to do the reduced form. Hey, all you got to do is count them out. Okay, what do you think's next? 1 pi, 7 pi, what's next? We're going up by 6, aren't we? Right? So the next one's going to be up 6, so that's going to be 13 pi over 12. Agreed? 7 plus 6 is 13. Okay, 1 plus 6 is 7. Okay, then what's the next one in your head? 19 pi over 12. Okay, you see what I'm doing? All I'm doing is I'm adding 6 pi over 12 to it. Okay, go to the next one. You have 1 pi over 6. What's next? 7 pi over 6. It's going up 3, isn't it? Okay, so it goes up 3, so now that's going to be 7 pi over 6. And then up 3 from there is 10 pi over 6. There's your 8 answers. Now you need to reduce the fractions. So the best way to write the final answer, and it doesn't matter what order, is you just have pi over 12, that's reduced, 7 pi over 12, 13 pi over 12, 19 pi over 12, and then write the rest of them out. Pi over 6, that's reduced. Okay, 4 pi over 6 reduces to 2 pi over 3. 7 pi over 6 is already reduced. And then finally, 10 pi over 6 reduces to 5 pi over 3. And that's the answer. Okay, isn't that a lovely problem? Yeah, some people are shaking their head this way. Some people aren't. Okay, it is a lovely problem. It's a lot of work. I don't usually ever test over this because it's long and it takes a lot of work. But I do this on the homework because you want to see how to manage that and everything. So if you follow the steps on this, you'll do okay. But you've got to, once you get the formula, when you get that formula, if you get that correct, then it's just a matter of let k equal 0, then move on to k equals 1, k equals 2, and so forth, and then that's it. Now see what happens on this. The biggest answer that I got on this problem is this one right here. Okay, that's almost 2 pi. So once you get beyond that, if you went on from there, if you went to the next one, see if you went up 6 from that, you'd have 25 pi over 12. Now let me ask you this question real quick. Are you guys clear that 25 pi over 12 is bigger than 2 pi? Yeah, because 25 over 12 is bigger than 2, agreed? So that one is no good. If you did this next one here, if you went up 3 from here, you'd have 13 pi over 6. Is that bigger than 2? Absolutely. 13 over 6 is 2 point something. That's why you stop. So now we have all the answers. Okay, what do you think? Okay, it's not that bad. Okay, it's all doable. Okay, so I'll finish up tonight then.